Hello everyone. So this is the third video on salt analysis, and this is the sample which has been given to us today to analyze. In salt analysis, what we do is we are going to detect the acid radical and the basic radical that is present in the given salt. So before going to the detection of acid radical and basic radical, so let us start with preliminary test. In preliminary test, what we are going to do is we are going to check the state of the salt, color as well as solubility test. So if you are going to see the salt properly, you can notice that there are some crystals in the given salt, isn't it? So the state of the salt is crystalline. If you are not able to identify by looking at the salt whether it is crystalline or amorphous, do one thing: take a pinch of the salt on your fingertips like this and rub it. If you are going to feel some crystals, then it is crystalline salt. If no, then it is going to be your amorphous. So by looking at the salt itself, we can even tell. So this salt is crystalline, and color, actually it is white in color, which we consider it as colorless. Okay, and the third preliminary test that we are supposed to do is the solubility test. How to carry out the solubility test is we are going to take the test tube. Just a second. Yes, we are going to take the test tube. In that, we are going to add a small quantity of the salt, and to this we are supposed to add distilled water. Okay, after adding distilled water, shake it well. Okay, so you can see that the salt is completely getting dissolved. Okay, which confirms that the salt is in the crystalline salt. Please remember, if the given salt is soluble in water, then it is crystalline salt. If it is not soluble in water, then obviously it will be soluble in dilute HCl. At that time, it will be in the amorphous state. But in today's salt, because it is crystalline, it is soluble in water. So we have completed with the preliminary test. After completion, what you people do is write it in the notebook. Okay, just we will write whatever observation we have got in the notebook. Okay, so as you can see, the heading is systematic qualitative analysis, and we have made 3 columns. The first one is test, which we have to perform. After performing the test, whatever observation we are going to get, we are writing it in the second column, and the third column is inference, that is nothing but conclusion. So first we have performed preliminary test. In that, it is state. So the state of the given salt is crystalline, which means the salt may contain carbonate, zinc, yes, the state of the given salt is crystalline, which means the salt may contain chloride, bromide, nitrate, sulfate, barium, aluminium 3+. These ions may be present. Okay, so if the given salt is crystalline, then the inference is going to be chloride, bromide, nitrate, sulfate, barium, aluminium. These ions may be present. Okay, it does not give any confirmation regarding the ions. It just gives a roughly idea which ions may be present. Okay, so the second preliminary test was color, which we got it as colorless, isn't it? In today's salt, the color is colorless. which indicates there may be barium 2 plus, Mg2 plus, zinc 2 plus, ammonium NH4 plus. These ions may be present. Okay, these ions may be present. And the third test, preliminary test, that is solubility test, also we have conducted, that is salt plus water, shake well. The observation that we got is the salt is soluble in water. The salt is soluble in water. So the inference is the given salt is crystalline. The given salt is crystalline. Okay, so this is about the preliminary test. Then we will go for detection of acid radical group. So let us begin with group 1 of the acid radical. So how to conclude that group 1 is present or no? By performing the test called as dilute H2SO4 test. In that test, what we are going to do is, we are going to take a test tube. In that, a small quantity of salt. To this, we are going to add dilute H2SO4, that is sulfuric acid. Okay, look at the label on the reagent bottle. I am taking dilute H2SO4. Okay, so after adding dilute H2SO4 to the given salt, look at the observation. Okay, we are not getting any brisk effervescence. There is no action between the salt and dilute H2SO4. Okay, so the observation that we got is no action. Again, write it down in your notebook. No action. So the inference is going to be group 1 absent. Group 1 absent, that is, in group 1 the acid radical that is present is carbonate is absent. So we have started with detection of acid radical, and also we have performed the test for group 1, and we came to know that group 1 is absent. So next what we are going to do is, we are going to conduct the test for group 2. So which test we have to conduct? That is concentrated H2SO4 test. How to do that? We are going to take a small quantity of salt, and we are going to add a drop of concentrated H2SO4 to that salt, but the test tube that we are going to take, it should be dry, because we are using concentrated sulfuric acid. Okay, so we will conduct the test. I am taking a dry test tube. As you can see, to this I am adding a small quantity of salt, and again to this I am supposed to add sulfuric acid. Okay, this is sulfuric acid, concentrated sulfuric acid. So take a drop of concentrated sulfuric acid with the help of glass tube. Dip the glass tube in the concentrated sulfuric acid and then take a drop of it. Okay, so here you can see that the observation is reddish brown gas. Okay, I hope all of you can see that. Okay, at the sides of the test tube you can see we are getting reddish brown gas for this test, isn't it? So the inference is group 2 present and bromide may be present. Okay. So let us write it down in the notebook. So here it is, group 2 concentrated H2SO4 test. What we are doing is salt plus a drop of concentrated H2SO4. As I told, we are going to carry out this test in a dry test tube, isn't it? So the observation that we got is reddish brown gas, reddish brown gas, that too in cold condition. What does it mean? We are not heating the test tube and we are getting the reddish brown gas, that is reddish brown gas in cold condition. So the inference is going to be group 2 present, group 2 present, and in that we are getting bromide, bromide may be present. Okay, so we have got group 2 present. What is the next step? We are going to analyze. In group 2 we are having chloride ion, bromide and nitrate. Because we are getting group 2 present, the next step is we should analyze which ion is present in group 2. So what is the test that we have to conduct to analyze the group 2 is, in a test tube again you are going to take salt plus water plus silver nitrate. We will conduct the test. Yes, I am taking the test tube. In that I am adding a small quantity of salt. To this we are supposed to add distilled water, shake it well until the given salt gets dissolved in the water. Okay, and then you add silver nitrate to it. Okay, look at the label of the reagent bottle. The chemical that is present inside this reagent bottle is silver nitrate. Yes, look at the observation. It is pale yellow, isn't it? We are getting a pale yellow precipitate. Yes, so what we have done is we have taken salt in the test tube. To that we have added water and silver nitrate. I hope you people can see the pale yellow precipitate. And this pale yellow precipitate should be soluble in excess of ammonium hydroxide. Already I have taken ammonium hydroxide in one more test tube. So what we will do is, whatever pale yellow precipitate we have got, we will slowly add this one into ammonium hydroxide test tube. Okay, test tube containing ammonium hydroxide. So look at the observation. Don't add too much at once, little bit. Okay, see this, it is soluble. So the observation that we got is salt plus water plus HeNO3. We are getting a pale yellow precipitate soluble in excess of ammonium hydroxide, which confirms that bromide ion is present. So let us write it down in the notebook. Okay, analysis of group 2, salt plus water plus AgNO3. This is the test which we have performed now. The observation that we got is pale yellow precipitate soluble in excess of ammonium hydroxide. The formula is NH4OH and the inference is bromide ion is present, Br minus is present. Okay, so we have started with the detection of acid radical group. In that we got group 2 present, and after analysis we came to know that bromide ion is present. Then we will go for confirmatory test for group 2 radicals, that is in that confirmatory test for bromide, and the test that we are going to conduct to confirm the presence of bromide ion is globule test. So how to do that is, in a test tube we are going to take salt plus chlorine water plus chloroform and we are going to shake it well. Okay, so let us conduct the test. I am taking the test tube. In that salt, small quantity of salt, and then we are going to add chlorine water. Okay, yes, look at the reagent bottle. It's the label reads it is chlorine water. So I am going to take the chlorine water in the test tube containing salt. Okay, to this we are supposed to add chloroform. Look at the label. Here it is written that it is chloroform. Okay, okay, after adding chloroform, shake it well. Yes, so you can see here at the bottom what you are getting is orange red globule, isn't it? At the bottom you can see here, I think it is nothing but the orange red globule. So this confirms the presence of bromide ion in the given salt. Okay, so just write it down in the notebook. So confirmatory test for bromide, the name of the test is globule test. What we did in this is, we took the salt plus chlorine water plus chloroform, shake well. The observation that we got is orange red globule, orange red globule, and the inference was Br minus is confirmed. So in today's salt, the acid radical that is present is bromide ion. Okay, so here we have completed the detection of acid radical. Okay, whatever salts has been given to you people, it will contain one acid radical and one basic radical. Already you have confirmed with the one acidic radical. Now let us go for detection of basic radical group, and the group number that we are going to conduct now is group 0. Okay, so how to analyze whether there is 0 group radical or no? By conducting the test. How to perform the test? First we are going to take the salt. In that we will add dilute NaOH, sodium hydroxide, and then we are going to boil it. Okay, I am taking the salt in the test tube. To this I am going to add sodium hydroxide. Okay, Yes, you can see the label on the reagent bottle, that it is sodium hydroxide. To the salt I am adding sodium hydroxide. What we have to do now is we are supposed to boil it. Okay, so as I told, we are going to boil this. This test tube contains salt plus sodium hydroxide. We are going to boil the mixture with the help of Bunsen burner. Please keep in mind, whenever you are boiling in the test tube, hold the test tube in the slanted position, and the face of the test tube should not be pointing towards the face of anyone, even your face. Okay, and it should be with continuous shaking like this. Yeah, this is sufficient. After boiling, immediately check the smell of the gas that has been evolved. Okay, yes, I am getting the pungent smelling gas, that is ammonia, which is evolved. And let us check whether it will give white dense fumes or no with a glass rod dipped in concentrated HCl. Okay, already I have taken a glass rod which is dipped in concentrated HCl. Just I will hold it to the face of the test tube. I hope you people can see the white dense fumes that has been evolved, isn't it? Yes. So the observation that we are getting here is pungent smelling gas ammonia is evolved, which gives white dense fumes with a glass rod dipped in concentrated hydrochloric acid. Okay, so let us write it down in the notebook. Okay, here it is: detection of basic radical group, analysis of zero group, that is for ammonium, and the test that we had conducted is salt plus dilute NaOH solution and boil. After boiling, we got pungent smell of ammonia, which gives white dense fumes with a glass rod dipped in HCl, that is concentrated HCl. And the observation, this is the observation, the inference is zero group is present, that is ammonium, NH4 plus is present. Okay, so this is the inference which we got after performing the test for group 0, that is ammonium is present. So what we will do now is we will perform the confirmatory test, okay, to confirm that ammonium is present. And the test that we are going to carry out is called as Nessler's reagent test. How to do is, in the test tube we are going to take a small quantity of salt. To this we are going to add sodium hydroxide. You can see this one, I think. Add slightly excess, okay. Yeah. So what we did is we are taking the salt in the test tube. To that we have added sodium hydroxide, slightly excess, and for this we are going to add Nessler's reagent. Okay, I hope you people can see the label on the bottle that it is Nessler's reagent, and I am adding that one to the test tube. Okay, yes. So after adding the Nessler's reagent, to the test tube, what is the observation we are getting is reddish brown precipitate, isn't it? A reddish brown precipitate is formed, which confirms ammonium is present in the given salt. So let us note it down in the notebook. Yeah, confirmatory test for ammonium. The name of the test is Nessler's reagent test. What we did, salt plus NaOH, sodium hydroxide, slightly excess plus Nessler's reagent. The observation that we got is reddish brown precipitate. Reddish brown precipitate, and the inference is ammonium radical is confirmed. Okay, so the basic radical in today's salt that is present is ammonium. Already we have detected the acid radical, that is bromide, and the basic radical that is present is ammonium. Okay, so we have detected both acid radical as well as basic radical. So this ends up the today's salt analysis. Before winding it up, we are supposed to write the report, which is very important. Okay. Yes, as I told, we are at the end we are supposed to write. Yes, at the end, as I told, we are supposed to write the report. The positive radical is NH4 plus, which we have confirmed now by Nessler's reagent test. Positive radical is nothing but the basic radical. Second is the negative radical is bromide, which we have confirmed by the test called as globule test. Negative radical is also called as acidic radical. The formula of the given salt is ammonium bromide NH4Br, and the name of the given salt is ammonium bromide. So this completes today's salt analysis, that is salt number 3. So in the given salt, the positive radical or the basic radical that is present is ammonium, and the acidic radical that was present is bromide. So the name of the given salt in today's salt is ammonium bromide.